Hello and welcome to EE233. I'm your TA, Blake Wingard, and in this video we're going to be looking at creating arrays on the stack versus the heap. This video assumes that you have watched the setup for your pointers demo, and it will also assume that you have access to the stack versus heap snip file. But without further ado, let's just dive right in. Go ahead and copy our function prototypes and our function definitions. Okay, and now we're just going to go ahead and include our switches. The first one being for the create array stack and the create array heap. Let's clear that out of the way and update our help. And so we're just going to get the name, boom, and the description. We'll just go ahead and use this. You can make yours better if you feel the need to. And we're going to get the heap. And let's go ahead and grab that. Let's shrink this up a little bit to try and make it look a little nicer. Okay. And now, without further ado, let's just dive right in. Notice that the create array functions return a pointer to an integer. That is how we'll be accessing the arrays. So let's go ahead and declare one. The functions themselves also take an input of length. Length being to describe how long the array should be. So as we can see in the description, that it's going to create an array where each element is its index. So for example, the create array stack with an input of 3 will return an array of length 3 with the elements 0, 1, and 2. So we have two choices here. We could try and choose a hard-coded value as something arbitrary, or we could make a variable parameter. I am a fan of variable parameters, so what we're going to do is we're going to throw in an AND condition, and we're going to need our argument count to be at least 3 elements. Oops, greater than equal to. Minor typo, and we're going to do the same for the heap. Alright, so we got an array. We're also going to get a length. And let's go ahead and initialize our array to null and our length to 0. The very first thing we need to do is we need to get the length, which will be an input argument. And so for that, I'm just going to use array to int of argv2. And what this will do is it will take the string passed to it and convert it to an integer. We're going to do the same down here. And now we can call our create array stack function with the input length. Copy that down here and replace that with heap. Let's go ahead and implement our first function, the create array stack function. Oddly enough, you all have already seen this before, or at least most of you should have. The way you declare an array on the stack is you simply type out the type of array you want, and you put a brackets with the size you want. So we have now created an array of length, and let's go ahead and assign its values using the for loop. minor typo. And as stated in the description, the value at each index will be the index itself. In order to view the array, I have created a little helper function known as display array, which, as it's written right now, we also have this little comment on whether we should be making this a constant array. The general consensus is that when you're doing things with displaying, printing, or whatnot, it would be to make it constant. As a matter of fact, if we look at the definition, so navigate to the definition, you'll see that printfs and its others also use constants. This is because there's no reason to be modifying the input string coming into it, and likewise there's no reason for a display function to change the value of the array. So let's go ahead and make one little update and turn that into a constant integer array. You'll need to do the same at the top. And now what are our return options? Well, we're going to come back to that one. But for now, let's just go ahead and display our array. So I'm going to keep this pretty simple. I'm going to loop through each element and print the value. You are welcome to get as fancy with this as you want. You could do something like array brackets index is equal to %. It's equal to the value. However you want to do it. But I am simply going to print the value delimited by a space, and then after it's all said and done, a new line to cap it off. Now we have a nice little display array function. Let's go ahead and include it. So we need to give it the array and the size of the array, and display array. Alright, now that that's done, let's just go ahead and test it out. So build, and I already have the command prompt in the proper directory. I'm going to make this a little bit larger. And let's go ahead and run our example. Print. There we go. It's giving me a little bit of issue after I resized it. So pointersdemo.exe, create array stack, and let's go ahead and give it a value of 5, and let's see what this looks like. I had a typo. Create ends with an E, and there we go. We have created an array of length 5 with the elements 0, 1, 2, 3, and 4. Alright, looks like it works. Now all we gotta do is return it back to the caller, and we're all well and dandy, right? Well, not exactly. And the best way to see that would be to simply display the array again. So, the created array, just to grab a little more detail, and watch what happens when we use our display array function after we return. And I put this in the wrong spot, but we're going to need it later anyway, so go ahead and leave it and just copy it up. So let's build. And notice that we're getting a warning. The warning is telling us that our function returns an address of a local variable. Why is that a problem? We'll come back up here. We'll run it again. Notice that it still works fine, just like it did before, but when we try to display the array after leaving the function, the array is gone. What's happening? Well, we called our function, and what happens when you call a function is it gets put on a stack, and you can physically picture this like stacking some plates. Alright, so you put a plate down, that's your main function, and then we're going to call our create array, that's another plate function going on top. And inside that second plate, is our array. It exists within the plate. So we can stack plates on top of that, and we're fine. The array will still be there. But when we take that plate away, which happens after you return a function, then the array is freed to memory. And so what happens is we're getting back null. And to prove that, I'm going to print out the address of the array. So we have the outside address, and we're going to go ahead and copy that. Let's go put it right here. And now we have our inside address. Oops, too far. And watch what happens. Write it again. And so you see inside our array has an actual address that's usable, but outside it returns null because it was freed on the stack. Now there are things we can do that would negate that and allow us to still use it, but in general there's a far better, far easier, and safer way of returning arrays from a function, and that would be to simply put it on the heap. So if the stack is a stack of plates, the heap is just a section of memory that you throw in a variable and use it wherever you want, however you want, with some exceptions. That's a very hand-washy explanation. The more technical one is that it's on the opposite end of the memory spectrum. So for example, if you picture the memory as a tower, I believe the stack is at the top and the heap is at the bottom, so that they build inwards towards each other and helps prevent overwriting and corruption and all that nasty stuff. But what's nice about the heap is because it's this different section of memory, when the function gets popped off the stack, you don't have to worry about losing it. It will still stay in the heap. Now, declaring it is a little different. In order to declare an array for the heap, first you need a pointer, and then you use a fancy little function known as malloc, which stands for memory allocation. So what we have to do is we have to tell our program how much memory we want from the heap. The way we do that is we need to tell it how big the actual element is itself. So that would be the integer. And then we can multiply that by the length in order to get back the length amount of elements. So just to reiterate, malloc takes an integer size chunk repeated length times from the heap. Okay. One thing to note about malloc is its return type is a void star. That is sort of C's way of having a generic type. So what we need to do is we need to cast it to an integer pointer. Okay. Once that's done, we can now initialize it just like we did in our create array stack. And we'll go ahead and display it. But we do still have this issue with the array stack, because when we came into that, our display function just had a heart attack and gave up. How can we resolve that issue? Well, since we know that the pointer we're getting back is null, we can use that value to make sure we're getting a valid array. So if the array itself is null, then we need to print some kind of message. So we'll put the array does not exist. And then this is where we can throw in our return value. So we have our results, and our results will assume optimistically that we're going to have success. And if we have an error, then we're going to have failure. So if the array is not null, we're going to carry on and do our normal function. And just to show you guys a neat little trick, you can highlight the code that's not properly indented, right click, and you click the format button, and it will indent everything for you, all nice and pretty. So our return value will no longer just be 0, but it will be our results. Let's go ahead and look at that real quick, just to make sure that works. So if we run it, so this time instead of just printing nothing, it prints that the array does not exist. Great. So now we've handled the issue of having a null array, which means that if our heap doesn't work, we'll know that. Because what happens when malloc has a memory allocation error, it itself will return null. And there could be a number of reasons why it'd have issues. Maybe you've managed to fill up the memory somehow, or there's just something weird going on in the process, and when that happens, it will return null. And so it's generally a good idea, after you use malloc, to check if it was null. So if the array was null, then we want to print out some message. We'll print out a warning. Array created on heap failed. That's a nice simple warning message. And then we'll want to, well, and there is one other issue. So if our array is null, we don't want to try and access the elements. Because if we try to access an element at null, we're going to have a crash. So we'll go ahead and wrap that in curly braces. So if it's null, then we want to print out our warning, and we can let whatever else is going on just happen. But we do want to still have that formatted. And there we go. Nice, pretty format. Ooh. Let's make that look a little bit better. All right. Now that's all said and done, we've handled our edge cases with malloc. We've handled our edge cases inside our display array. We should be good to go. And let's actually test our heap function. We know this warning is for the stack, so we can ignore it. All right, so instead of create array stack, we're going to create array heap, which, as you can see, after we leave the function, returns the proper array. We do still have one other issue, though. The nice thing about arrays created on the stack is they are freed after the function itself leaves. Once we pull the plate off, the function is gone. Once we pull the plate off, the array is gone. But with the heap, it's still there. So, how do we get rid of it? Well, there is a little function known as free. So what we have to do is free the array. And the reason you'd want to do that, by freeing the array, you are giving back the memory to your program. Now, if you forget to free some memory, it's not a huge deal, as when the program finishes its life cycle, that memory will automatically be freed. However, freeing becomes important in a long-running program. Otherwise, you run into things such as memory leaks, which are nasty little things that can fill up a program's memory and cause it to crash, which you don't want. So this doesn't do visually anything different, but it makes our program a little more robust. The advantages to using something on the heap is that we can actually change the size of the memory, as opposed to a array created on the stack. That is a fixed length. So for example, we've been creating arrays of length 5. If I all of a sudden want to make our array have 10 elements, I can't change the stack array. It is fixed with 5 only. But with the heap, I can actually change the size of it, but that is going to be a topic for another video. So the heap gives us this potential for dynamic arrays, which are hopefully going to be something you'll be covering very soon. I hope you found this video helpful. If you have any questions, please reach out to your TA or your instructor. And thanks for watching.